Welcome to Ask and Learn.
So let's solve this question by first finding out the net capacitance of the capacitor formed here. So this is 2 millimeter glass and this is 3 millimeter air. So K here is not 1 but 5.8. So we know that this is series capacitance. So let's use series capacitance formula. C1, this is C air, and C2, which is C glass. Now, we know that capacitance looks somewhat like this: A epsilon naught K divided by D. Let's substitute that in here. So 1 over C is equal to, so we have 1 divided by A epsilon naught common. Inside, we will have D divided by K. So dA divided by Ka plus D glass divided by K glass. Now let's substitute the values. 1 divided by area is 1.45 times epsilon naught is 8.85 times 10 power negative 12. Then we know that distance in air is 3 millimeters, so that's 0.003 meters divided by 1, plus we also know that the distance of glass is 0.002 divided by 5.8. Now if you perform this calculation, you will get, so let me do that on my calculator. So the bracket terms is 0.003344, then multiplying it by area and the epsilon naught value, we get 3.84 nanofarad. So that's the net capacitance. Now we can use this net capacitance to find the charge on the plate, which is equal to CV. So just we need to multiply capacitance by the potential applied. So this gives us the value 0.345 microcoulomb. So this is the charge on this plate up here, which is, let's say this is positive, and this here is negative. So let me see the circuit diagram again. Yes, that is right. Now this positive charge will induce some negative charge over here. So let me magnify this glass surface. It will look somewhat like this, with the negative charges on the top surface and the positive charges induced again on the bottom surface. Now we are going to use the fact that electric field is decreased by the factor of K. So electric field inside the glass is equal to electric field inside the air divided by K. So let's find out electric field. First. So electric field inside the air, which is simply sigma divided by epsilon naught. We know that sigma is charge divided by area and epsilon naught. So charge, as we know, is 0.345 microcoulomb divided by area is 1.45 and divided by epsilon naught, which is 8.85. This gives us the value 0.0268. So the value here is 0.0268. Now let's this q came with the factor of 10 power negative 6, and epsilon naught has a factor of 10 power positive 12, negative 12. In the numerator is positive 12, so 10 power positive 6. So that's the electric field that we have. That means this is 2.69 times 10 power 4 Newton per Coulomb. So let's use that in here to find out electric field inside the glass. So all we have to do is divide this number by the K. So if you do that, you will get 4.64 times 10 power 3 Newton per Coulomb. So this is electric field inside the glass. Now, electric field inside any material is sigma, which is charge, minus induced charge divided by epsilon naught. So this is induced charge density. So let's find out induced charge density, which is equal to epsilon naught Eg sigma minus epsilon naught Eg. So let's do that. So let's not do this calculation because we need let's find out Q directly. So all we have to do is multiply both sides by area. So Q induced is equal to Q, this sigma is a sigma plate, so this will give you Q plate, minus A epsilon naught Eg. So let's do this calculation. Q induced is equal to, as we know, Q plate is 0.345 microcoulomb, 0.345 microcoulomb, minus area, which is 1.45, epsilon naught is 8.85 times 10 power negative 12 times the electric field inside the glass, which is 4.64 times 10 power 3. So let's do this calculation. 1.45 times 8.85 times 4.64. So this results in 5.97, sorry, 0.597 times, so this is 10 power negative 12, this is 10 power negative positive 3, so that's 10 power negative 9, and I by writing in this way I made it 10 power negative 7. So we are subtracting, in the end we are subtracting 0.345 minus 0.0597 microcoulomb. So let's do this one. So you get the value 0.2853 microcoulomb. So this is induced charge. Now let's draw the electric field. So electric field, as we know, is again parallel and constant in given material. So even inside the glass, it's constant. But this one is Eg and this one is Ea. So it has higher magnitude up here, lower magnitude inside the material, and thereby increasing the capacitance. Thank you.